Okay. Um, any questions on 13, 14, 15, 17, 22, or 44? 22. And 22 is going to be the worst one. Not only do you have to solve for 3 letters, but you also have to evaluate when you are done. So let's look at this new page. Do I have a title page for y'all? I do indeed. And we get to use Heaviside on this one. Come on. Waiting for this thing to start responding. What's tomorrow's dress up day? Disney? Okay. I have some Disney t-shirts. This whole week has been Disney. It's like Star Wars and then Marvel and then Disney and I guess it wasn't technically Star Wars, was it? It was Space Day. Okay. So, gonna set up my fractions here. We can calm down a little bit. Everything okay? A, B, C. To solve for A, yesterday's warm up had something similar to this, where you just had like an A over an X that you had to solve. And a few people plugged in 1. They thought maybe 1 made Y equal to 0. Or maybe that was fifth period. Because y'all turned it in before I showed you the Heaviside method, didn't you? Okay, so it was fifth period. It's not did that. Anyway, what makes Y equal to 0? It's not a trick question. It answers itself. 0. Yeah. So I'm going to plug in 0 for every Y except for that one. So I'm going to get that out of the way. And 0 is a nice one because I'll be 0, 0, negative 12 over 2 times negative 3 is negative 6. And I now know that A is equal to 2. Good. Now I need to plug in negative 2 because that makes what's under my B 0. And so I will end up having a B of. Let me block this out. Oh, crap. I'm going to have to do this. So 16, is that right? Negative 2 squared is 4. So 7, negative 7 times negative 2 is plus 14 minus 12 all over negative 2 times negative 5 is 10. Is that right? I messed up somewhere. That's ugly. Negative 2, negative 5 is positive 10. Is this what y'all got? Oh, this is ugly, isn't it? 30 minus 12 is 18 over 10. 9/5. Did y'all get that? Oh, man. What a stupid problem. All right. On to C. I'll plug in 3 for my y's, except for the y minus 3. And C is going to equal 4 times 9 is 36, minus 7 times 3, minus 12, all over 3 times 5. So what's that, 25? Is this ugly too? No, 15. 15 minus 12 is 3. That'd be 1/5. This is stupid. Who invented this problem? Okay. So then we have to do the antiderivatives of those. And this again, if you need to write it in 3 separate antiderivatives, it's 2 over y plus 9/5 over y plus 2. And I think what I may do is go ahead and pull those constants out. Is that okay? Because I can tell that my bottom denominator, my bottom derivative is a 1, and I would like to see that 1 in the numerator. So I have that natural log set up. 1 over y minus 3. And so we have 2 natural log y plus 9/5, natural log of y plus 2 plus 1/5, natural log of y minus 3. And then all of that evaluated from 1 to 2. And this problem is just annoying. I don't know if is it difficult or is it just annoying? Or is there a difference? I don't know. I need to plug in 2. So when I plug in 2, I'll have 2 natural log of 2 plus 9/5 natural log of 4 plus 1/5 natural log 2 minus 3 is -1, but we're absolutely valuing that. Minus plug in 1, 2 natural log 1 plus 9/5 natural log of 3 plus 1/5 natural log of 2. And I would just leave it like that. You can ignore the ln1s, that those equal 0. So if you want to drop those out, you could combine natural log 2 terms, but I don't see any real benefit to doing that. So that was rough. That's probably the hardest one of the ones that were remaining. Maybe? Pretty good. Another one that you want to look at? Is there another one? 17. Let's see what happens here. Another one that you evaluate. Okay, so you know what I forgot to do on this one? Oh, but it wasn't expanded, so yeah. So this one, I'm going to check really quickly. The top is not the derivative of the bottom. That would have been nice. So we will go ahead and factor that bottom. So it's x minus 4 over x minus 2x minus 3 equals a over x minus 2 plus b over x minus 3. A, to get a, I will plug in 2 for my x. And so it'll be 2 minus 4 over 2 minus 3, and a is 2. Is that okay? Too fast? Plug in 3 to get b, so 3 minus 4 is -1. 3 minus 2 is +1, so b is going to be -1. So no fractions. This one's a lot cleaner. And when you do those antiderivatives, you're doing the antiderivative of those new fractions. If you pull that 2 and the -1 out, then you would have a top that is the derivative of the bottom. So the antiderivative becomes 2 natural log x minus 2 minus 1 natural log of x minus 3. And then we would evaluate from 0 to 1. See what happens. 2 natural log 1 minus 2 in absolute values would be 1. Oh, that's nice. Minus natural log of the absolute value of -2 minus 2 times the natural log of the absolute value of -2 minus the natural log of 3. Are we good? Good. Now, just for fun, and I was thinking about doing it when I started the last problem, but the last problem ended up being so ugly, I decided to just stop when I had all numbers. But this one will clean up relatively conveniently because we have negative natural log 2. Remember, ln1 is 0, so that one zeroes out. Minus 2 natural log of 2 plus a natural log of 3 could be rewritten. I have -1 ln2 minus 2 ln2. That's -3 natural log of 2. That's a natural log of 3. And this is just something that's good to practice because in multiple choice, they may do all this stuff. They may combine stuff. They would definitely combine it to at least this. They're going to combine the things they conveniently combine just through normal algebra. But they could go even further. What else could I do? Good. Natural 3 times the natural log of 2 is the same thing as the natural log of 2 cubed. So they could turn that into natural log of 3 minus the natural log of 8. And they very, very frequently do. But wait, there's more. One last little step. We could combine that. We are now subtracting 2 logs. We could combine that into the log of the quotient of their arguments. So just little annoying things that you have to be ready and comfortable doing. Yeah. Any others? No? Let's see. What else do we have? What was the answer to 44? Did we get an answer there? Is it C? I heard a lot of C's, so I'll go with that. I guess you had 1/6 over x minus 3 minus 1/6 over x plus 3 when you partially practically decomposited it. Maybe. And arctan is there just to. They should have put a 1/3 in front of that inverse tangent. Because if it were x squared plus 9, then it would be 1/3 inverse tangent of x over 3. So kind of a poor distractor there. Or maybe a good one. Maybe that's good for y'all. I don't know. Good, bad, ugly? No? Okay. I've got a few things I want to return to you. And while I am getting those things back to you, I want you to get this. Yes, ma'am. To 15? I didn't. What? 13. I don't know. Let's see. Where is 13? Oh, 13. I'm glad you asked 13. What did y'all do with 13? Because I definitely wanted to do 13. I just forgot about it. That is not a partial fractions problem. Partial fraction decomposition really can only be done when you can factor your denominator into multiple factors. So this is like a throwback to old techniques. What should we do? Hmm? Yeah, we have to divide. My top degree is not less than the bottom degree. So you can't do anything. You could go through a substitution method with a double substitution, and it would work if you let u equal t plus 1, but it's a lot more complicated. We're just going to divide the bottom into the top. Now, you said long division, which will work. I can synthetically divide this one because it's just a 1t plus 1. So I'm going to divide the bottom into the top. So it's negative 1 into a 3t minus 2. Bring down the 3. Negative 1 times 3 is negative 3. There's my remainder of negative 5. And so I can rewrite this whole thing as 3 plus a negative 5 over a t plus 1. We good? Which then, the antiderivative of 3 is 3t. What do you think about the antiderivative of negative 5 over t plus 1? Yeah, take the 5 out, and once you take that 5 out, the top becomes the derivative of the bottom. And there's your answer. That's one that it falls back on older techniques. Always consider those other things before you just jump into whatever we're doing for the day. They sneak something in on you. You're good? You're good? All right. Now, as I was saying, are there any other questions? Thank you, Ms. Jones, for bringing that one up. I gave y'all. Why do I have so many windows open? This I gave you yesterday. This is a throwback to earlier stuff from earlier this semester, USUB and earlier. But let's look at this and see what we can do. And it's similar to the warm-up today. Similar to the warm-up. We need to remember how to do these things. So see what you can do with this. I'm going to pass back some stuff that I have. I did some grading of warm-ups and stuff last night. I need to update grades. A handful of you took your first thoughts quiz, and I still haven't put it in for you, but I've graded it. All right, pause everything. So number 1, again, no calculator. And we are having a free response quiz on Friday that will touch up on, that'll be based on questions similar to this. I may, kind of like the second problem. Why did it freeze? Unfreeze. There we go. I may give you a graph to go with it, kind of like the second question down there. But let's see. So A, find f of 2. The very, very first step is mind-bogglingly easy. What would I do very first? Just plug in 2 for the, that's what f of 2 means. Going back to like what you learned in 7th grade, it's a weird equation, it's a calculus equation, but it is an equation for f of x. F of 2 means just plug in 2 for the x. So when I said the first step is mind-bogglingly easy, I meant the very, 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 very first step that some of y'all may not even consider a step at all. So that's all I was talking about. F of 2 means replace the x's with a 2. Then we have to look at that and decide how in the world do we evaluate it. This is where it gets difficult. How would I figure out what that is? Any ideas? Y'all mad at me again? It's a definite integral. So we have to find the antiderivative, plug in. What kind of antiderivative would this be? Okay, go down the list. Is it recognition or power rule? I'm going to say no to that, although theoretically you could expand it and turn it into a power rule. But I'm not going to do that. If it's not recognition or power rule, I always try U substitution first. So is there a reasonable choice for U in this one? Usually if there's something in parentheses, especially if something is happening to those parentheses, like being raised to the 4th power, then what's in those parentheses very, very frequently is your U. But that can only work if the derivative of that shows up in the problem. Is the derivative of t squared is 2t, and dt is part of it. Can I make a 2t dt happen? Yep. If I put a 2 and a 1/2, I've got my 2t and my dt. So this sets up very nicely for U substitution. And I kind of prefer to do this off to the side, maybe even in your head. I'm not sure. But it ends up being 1/2 u to the 4th du, which would integrate to 1/2 u to the 5th over 5, or u to the 5th over 10. So then back to this, it's u t squared minus 1 to the 5th over 10. Then I need to evaluate from 1 to 2. You also have the option, and then I usually do this for whatever reason today, I just didn't. You also have the option of converting your limits of integration to corresponding values of u. If you plug in 1 and 2, your corresponding values of u would be 0 and 3, and then you could evaluate this guy over here from 0 to 3. As long as you get the right numeric answer in the end, you're good. So I would now plug in 2. Oh my gosh, what kind of number is this? 2 squared minus 1 is 3 to the 5th over 10 minus, plug in 1. Oh, that's sexy. You should get 0. Are we okay there? There's your f of 2. B. Find f prime of x. So f prime of x, now we're thinking our derivative rules. How do we do the derivative of something like this? These are nice. Yeah, you just plug the x in. Make sure you're going from constant to variable. You plug in x for the t, so it'd be x squared minus 1 to the 4th times the derivative of what replaced the t's. In this case, it doesn't matter if you forgot that because it's 1, but that needs to be a conscious thought. Very, very, very frequently people forget that part when it matters. In this case, it didn't. So that's all there was to B. B was just find f prime of x. So we have that. C, find the equation of the line. Stop! That is one of those phrases that we've been dealing with all year, and every single time I've asked you, what do you think about that phrase? What does it make you want to find? Equation of a line, you should immediately think that you need a point and a slope. That should be automatic by now. The point, and this was one of the questions on that first thoughts quiz, the point is almost always, if I want add x equals 2, the point is almost always just f of 2. Very seldom, but it can happen that you get it another way. The slope you almost always plug that number into the derivative. You have to be careful with this one. But that's kind of what I want you to do. Not kind of, that is what I want you to do. F2, F prime 2. Then think about how we get those two pieces of information, and it's going to be extremely easy because F of 2 was done in part A. I still don't feel like cleaning up 3 to the 5th over 10. I'm going to leave F of 2 as 3 to the 5th over 10. 3 to the 4th is 81, so what's 3 to the 5th? 243. But again, no point in cleaning that up. F prime of 2. Oh, we just found F prime of X in part A, so F prime of 2 would be 2 times 2 squared minus 1, which is 3 to the 4th. You want to clean that up? You could. Shouldn't be painfully difficult, but it does open the door to mistakes. I think I'm going to leave it like that for now. But be careful, because I asked for the equation of the line normal. What does that mean? Not same. Perpendicular. Normal is perpendicular. So what we just found was the tangent slope, therefore the normal slope. And again, I'm going to keep it easy on myself. It's the negative reciprocal of that, so it'd be negative 1 over 2 times 3 to the 4th, and that's acceptable. You don't have to turn it into a fraction of 2 integers. You can leave it in some weird mathematical something like that. Same thing with F of 2. That y coordinate is kind of ugly, but I know it's correct. And once you get your slope and your point, now we can go into point slope form. The answer will be y minus my y coordinate. I'm going to keep it ugly. 3 to the 5th over, that's not a 5. 3 to the 5th over 10 equals slope negative 1 over 2 times 3 to the 4th times x minus x coordinate, and you can leave your answer in that ugly format. How does that make you feel? Okay. All right. Now, blast from the past. Find where the function is decreasing. When does a function decrease? That also should conjure an immediate thought. When does a function decrease? Good. When your derivative is negative. We've got to figure out, how am I going to find when the derivative is negative? We have the derivative in part B. So part B, if I want f prime to be negative, I'm going to have to first find out where f prime equals 0. So f prime was x squared minus 1 to the 4th. I'll set that equal to 0, get my critical numbers. What are the critical numbers? 0, negative 1, and positive 1. Yeah. And to find out where the derivative is negative, we do that little number line. Remember, the number line is invisible. It's a beautiful organizational tool, but it does not count for any work shown. So make sure that you have sufficient work on your paper elsewhere to to support whatever you have on your number line. I'll put my critical numbers: negative 1, 0, 1. Those actually make my derivative equal to 0, so I put zeros up there. Then when you pick our test points, we have 4 test points to consider. Left of negative 1, between 0 and negative 1, between 0 and 1, and after 1. And these are going to be really nice to plug in. These are going to be very nice because I'm looking at my derivative and I see x squared minus 1 all to the 4th power. What's going to happen there? Anything I plug into that will be positive, right? Except 1 or negative 1, but I'm not going to plug those in anyway. I've already got those accounted for. Right? So that's going to make it a little bit easier. You still need to, if you can remember this from a long time ago, you need to actually write down f prime of negative 2. Actually write in mathematical language. You're plugging into the derivative. That'll be negative 2 times something positive. That's negative. F prime of negative 1/2 would be negative 1/2 times something positive. f prime of positive 1/2. Positive 1/2 times something positive. And the same thing for 2. So there's all the heavy lifting. And I want to go back and read the question for a second. Where is f decreasing? What would you say? What's your interval of decrease? On negative infinity to 0. Is that okay to go negative infinity to 0? Or should I stop at -1 and then go -1 to 0? I think we discussed this a long time ago. It's been a long time. Yes, Ms. Jones. Yeah. Not only can you say negative infinity to 0, you really should. Mathematically, that is the correct answer. Although on the AP exam, they won't penalize you, or I should say they have not yet penalized you if you do break it up at -1. But mathematically, it is more correct to include -1 in that interval of decrease. Good. What do we think of that one? That's like a good review problem. That's old stuff. Do y'all remember any of that? You can't really forget anything in this class, can you? It all comes back. Isn't that great? It's like long lost friends. Let's see how the next one looks. Is the next one scary? You know what I want you to do? What do we have? We have 13 more minutes. Should we stay on track with these kinds of questions or should we change gears? What do y'all think? Do we have an opinion? I will say, if you look at my answers to this one, I got really wordy. Like, if you look at the back, I like wrote a paragraph for part B. I don't know what I was doing. I was on fire, filled by the spirit of the gods of math. I don't know. No, let's go through this. Let's talk about this. We probably won't finish it because it does get a little bit wordy, especially. And I think I got a little bit wordier on this one because you don't have an actual equation to do math with. Kind of like on that last problem, we actually had an explicit derivative. We had an equation for the derivative, so it was a little bit easier to show how am I showing where something is positive or negative or whatever. So I think maybe I got wordy on my explanations just to make sure I covered my bases. I probably could simplify some of those justifications or explanations here. Goddard, how are you? Thank you. Okay. Number A should be nice. Pay attention to what you're looking at. This is the graph of f prime, the derivative of f, shown in the figure to the right. And again, it's labeled f prime up here. So make sure you pay very close attention to what you are actually looking at. I'll put my head back up there. A. Very, very common question. Find the equation of the line tangent to the graph at the point 3, 1. What do we need? Good, we need a point and we need a slope. They already gave me the point, so we don't have to actually plug 3 into the function. For the slope, you plug 3 into the derivative, and there are other ways of analyzing and getting the slope, but this is the method that works more often than not. Can I find f prime of 3? What is it? Be careful, there's 2 things I would expect to hear. One of them is a very common mistake. What is f prime of 3? It's 2, right? Because we are looking at the derivative, and there is very clearly a point graphed at 3, 2. So f prime of 3 is 2. Sometimes I'll hear 0 because people are imagining the tangent at that point, but that will actually be getting into second derivative territory. And so f prime of 3 is 2. So the equation of the tangent line, y minus 1 is 2x minus 3, and you're done. Cool? Cool. B, find all values of x on the open interval -4 to 4, at which f has a local minimum. Another word that should conjure an immediate thought. When you see local minimum, you should have, there's actually a couple of different things that, maybe even three things that can come into your brain, but there's usually one way that we find local minima. There's one more common way. What would that be? Good. You need f prime. This is what I want you to think. You want f prime to change from negative to positive. More specifically, add a critical number. But that's kind of our game plan. You can use concavity to justify local extrema. So there are other methods of figuring this out, but usually we think the derivative. So that's my game plan, and I'm thinking that without even looking at the graph. I see local minimum, I think derivative negative positive. Then I look at the graph. Does the derivative ever change from negative to positive? Yes. Where does that change happen? Local minimum at x equals what? 1. Are we okay out there? X equals 1, because I'm looking at the derivative, and my derivative is below the x-axis, then it is above the x-axis. That is a change from negative values to positive values. And the justification would simply be because f prime of x changes from negative to positive. I would encourage you to write the words out. I know sometimes I get lazy and I'll just put a minus sign and a plus sign, and they will allow that on the AP exam, but you're kind of taking a risk that your writing could be sloppy, or they may not be able to tell what you wrote by just a symbol like that. So I would encourage you to maybe get in the habit of actually writing the words, and maybe I should set a better example. F prime changes from negative to positive, and I would specify at x equals 1 again. And you don't have to explain why the derivative changes negative to positive, because we're looking at the derivative graph. If we were looking at the second derivative or the original function or something like that, maybe then we have to go a little bit further with our explanation. Cool? C is definitely a Carboni question, because they will not ask you to do this on the AP exam. Estimate f double prime of 2. So 2 is right here. Estimate f double prime of 2. How would I do that? We're looking at f prime. F double prime would be the slope, the derivative. So just kind of eyeball the tangent line. Maybe draw one. It's a little bit easier to see if you actually draw one. What do you think is a reasonable slope for that tangent? I would go 1. I'll say f double prime 2 is approximately 1. I like to keep my approximations as simple as possible. I mean, if you want to say 1.036, there's nothing wrong with that. But if you happen to need that later, you're making subsequent steps a little bit more difficult. They don't ask you on the AP exam to estimate specific slopes like 1, 1.5, things like that. But they have asked questions like this where you need to at least be able to tell if f double prime of 2 is positive or negative. That's big picture. That's not very minute estimating, but big picture stuff you need to know that f double prime 2 is positive. What would that mean if f double prime 2 is positive? Another immediate thought. That should come out immediately. Second derivative positive. Concave up. Yeah. All right. D, x coordinate of each inflection point on the open interval -4 to 4. An inflection point, that's another phrase that should make you think something immediately. When I think inflection point, what's the very first thing you should think of? Yeah, you need f double prime to change signs. If you have an inflection point, the second derivative change signs. That should be immediate every time, regardless of what's given to you, whether they give you an equation, a graph, a table of values. If you want an inflection point, you need the second derivative to change signs. The problem here is we don't have the second derivative, we have the first derivative. So how do I look at the first derivative and think about the second derivative? What do we look at? Yeah, it's the slope. Remember, derivative is kind of synonymous with the word slope. So the derivative of the derivative is the same as the slope of the derivative. So I need the slope of the derivative to change signs, which means you need to change from increasing to decreasing or decreasing to increasing. And it turns out everywhere, and this is also on that orange sheet, everywhere your derivative has a local extrema, as long as the derivative is continuous, everywhere the derivative has a local extrema is an inflection point. So those 3 points I just circled, x equals -3, -1, and +3, those are inflection points. And you can actually say because f prime has local extrema. F change signs at x equals, what I say, -3, -1, and 3, because, and it does say justify your answer, because f prime has local extrema. And again, even though I've already stated the locations, I'm going to restate it here at x equals -3, -1, and 3. I probably got a whole lot wordier on the back, did I? I wonder how long ago I put that together. Inflection points are when f double prime changes signs, which is when f prime changes from increasing to decreasing or decreasing to increasing. This happens at, so I just got a little bit wordier in describing a local extrema. Cool? And then in a couple of minutes, we can maybe finish this one. At what value does f achieve its maximum value on the closed interval 0 to 4? Oh, that's not at all what we wanted to do. The maximum value on the interval 0 to 4. Honestly, I'm going to say you don't know how to do that yet. As far as initial game planning, we could get to a certain point on this one. Anytime you see a maximum on a closed interval, that's an extreme value theorem question, which again is on that orange sheet. There are so many things that if you can get that orange sheet down, it gets you going in the right direction without you having to spend a lot of time thinking. Extreme value theorem, you want to consider the endpoints and critical numbers. My endpoints are obviously 0 and 4. Those are given to you explicitly. Critical numbers are when the derivative equals 0, which happens at 1, right? Then usually for extreme value theorem, what we've done is we've gone to our function. We said, okay, what is f of 0, what is f of 1, and what is f of 4? That's usually what we do. The problem is we don't have f of x, and that's where we don't have the skills yet to finish this problem. But you could at least game plan a little bit before you hit a brick wall. I'll post something simple, like maybe 3 multiple choice questions for homework, and we'll talk about that Thursday. Do I see y'all Thursday? I see y'all tomorrow. Tomorrow. Y'all have a great weekend.